Hey everyone, welcome to Code Harmony. Today we are going to solve this LeetCode challenge 2661. First, completely painted row and column. This question has been asked in Adobe and CTRL, and let's have a look on the problem statement. I will explain it to you with the help of an example. What is given to us and what operation we have to perform on the given input and what we have to return. So what is given is firstly an array and a matrix. This matrix is of size m cross n, and this matrix is containing all the elements from 1 to m cross n. Let's say in this case m is 2, n is 2, so the matrix is going to contain 2 into 2, 4. 1 to 4, all the elements from 1 to 4. So these two values are given to us, and what we have to perform is the operation. The operation is something, go through each element in this array given to us. Let's say let's mark the indices of this array 1, 2. Okay, we have to go through each element from it. First one is 1, second one is 3, third one is 4 and 2. And what we have to do is whatever element we are picking, let's say first element is 1, we have to mark the 1, or you can say paint the 1 in the matrix. Okay, first one we have painted the 1, second time we are going to paint the 3. So 1 is already painted, 3 we have painted. And what is the third one? Third item is 4. 1 is already painted, 3 is already painted, now we have painted 4. Okay, at this moment what we have to return? We have to return the index in ARR at which any one row or one column is painted in the matrix. Now at this moment, at index 2 in array, the first row is already painted. So this is what we have to return. Now let's read the problem statement. You are given a 0 index integer array ARR. So this is our ARR, 0 index integer array, and a matrix of size m cross n. Okay, this is our matrix. And array and matrix both contain all the integer in the range 1 to m cross n. Array is also going to have elements from 1 to 4 for this example. Matrix is also going to have 1 to 4 for this example. So this is given to us. What operation we have to perform? Go through each index I in array starting from 0 and paint the cell in the matrix containing the integer value. We are iterating over array from index 0 to the last index and paint the corresponding cell in the matrix. First value in the array is 1. So paint the cell containing 1. Paint the cell containing 3, paint the cell containing 4, and now at this moment, what we have to return? Return the smallest index I at which either a row or a column will be completely painted. So at this moment, you can see that this first row and the second column is painted. In this case, we are going to return 2 as our answer. So the answer to this function, answer to this example is going to be 2. This integer we have to return. Now this is my problem statement. At any moment, if any row or any column is completely painted, just return that index from array. Now what is going to be my approach? What we have to find out that any row or column is completely painted. We are iterating over our given array and we are painting the corresponding cell, and after painting the corresponding cell we have to make sure that if any one of the row or column is becoming completely painted. Okay, so this is the matrix given to us, and this matrix is of size m cross n. It means number of rows are m and number of columns are n. How do I keep track of that any row or column is completely painted? See, we are not concerned about the number of items which are painted. We are just concerned whether this first row is completely painted or not. Yes or no. That's all. One boolean value we require. So how do I find that boolean value? If number of elements in the first row, number of painted elements in the first row is equal to n, equal to the number of column, then we can directly say that the first row is completely painted. Okay, now this is the first row. How many elements are there in the first row? N elements are there. So if number of painted elements in the first row is equal to n, in that case we can directly say that the first row is completely painted. It means the number of painted element, if I am stored somewhere, what is this value? This is an integer value. So if I store an integer value corresponding to the first row, this integer value is going to contain number of painted cell in first row. That's all. And same thing I can do for the column. Let's say this is the last column, and in this column, how many painted cells are there? I can keep track of in this array. In this array, if I just keep track of number of painted cell in column corresponding to the same index, this value I can store. If the number of painted cell in a particular column is becoming equal to number of rows, it means that column is completely painted. So what I can say now, if we are taking two array to store the number of cells in corresponding row and column, then we can easily say whether after painting ith cell from array, whether the column is getting completely painted or row is getting completely painted. We have to take two arrays. First one you can say row count. Row count is in every row count the number of painted cells. What should be the size of this array? Equal to the number of rows. New integer of size m. And I require another column as well. Column count. Count of the number of painted cell in a column. That is also equal to number of column. So these two array will be useful for us to keep track of the number of columns which are painted. Let's say this is the column array and this is the row array. If the value at this moment that column 2 is having number of painted cell equal to m, then I can easily say that at this moment I'm getting my answer. Okay. Now let's take the array. Take the same example. Rest you will be able to understand easily. Okay, let me remove these items. This is our example. And now what I'm telling you is just take an array. This is the array for row. Row count. Going to have 2 elements. And this is the array column count. It is also going to have 2 elements. Initially it is 0. 0, 0, 0, 0. No painted rows are there. Okay. Then my problem is, given problem statement is that we are going through every single item in array starting from index 0 and we are going to paint the corresponding cell in the matrix. First cell is 1. I'm going to paint 1. When I'm painting 1, I can easily say what is the row and column of 1? 1 is having row and column equal to 0, 0. Okay. It means 0th row, 0th column. So in the 0th row, count the number of painted cell. In the 0th column, increment the number of painted cell. So row count, column count will be incremented for the corresponding cell. Now we will move to the second item. First item is covered. Second item is 3. Second item is 3 and now I have to paint 3. Okay. Now I have painted 3 and what is the coordinates of 3? Coordinates of 3 is 1, 1. It means first row and first column according to indices will be incremented by 1. There is one more painted cell in the first row and there is one more painted cell in the first column. Okay. Now this is the state. So every time, every ith time, what I'm getting, I need the coordinates of the particular value. I require the coordinates of the particular value. Then I will update my row count and column count array. Let's move ahead. Third item is 4. Let's paint 4. When I'm painting 4, fourth, coordinates of the fourth are 0, 1. It means 0th row and the first column. When I'm updating the 0th row, while I'm going to update the 0th row, I'm removing it and I'm putting 2 here. 1 plus 1, 2. Now at this moment, just stop at this moment, because at this moment, this row count is becoming equal to total number of columns. It means first column, second column, 0th column, first column. Yeah. If it is becoming equal to 2, at this moment, we have to stop everything. It means we have found our answer at this index. So this index is becoming my answer. What is this index? This index is 2. This is the solution. So in short, what we did is we are iterating over the array given to us, and for every ith index, I am calculating whether the row count or column count is becoming equal to the desired one. So based on that, I am just getting my answer. And see, there is one more thing that you need to solve. First one is getting the coordinates of every value. The value is 4 here, and get the coordinates of 4. How do you get the coordinates of 4? For that, you can take a hash map. Hash map. Because all the values are unique. It is also given in the problem statement. See, all the values on the array is unique. All the integers in the matrix are unique. And they are containing values from 1 to m cross n. The matrix size is m cross n. And all the values are unique, and it is going to have values from 1 to m cross n. It means all the values are unique. It's also like understood. If they are having values from 1 to m cross n, they are going to have all the values from 1 to m cross n. If all the values are unique, then we can take these values as a key to my hash map. And for the value, I can take my coordinates ij. This you can take the hash map. Key is your value, and coordinates, key is your value from matrix, and the value in the hash map is the coordinates. So this is my hash map. Why I'm using hash map? Because I will be able to prepare the hash map in m cross n time, and after that, whatever value we are getting in array, we can go to the corresponding matrix cell in order of 1 time. Order of 1 access time from matrix. Okay. So this is the first step we have done. And after that, see, you have the key, you can get the coordinates, and if you have the coordinates, you can reach to the corresponding cell, row count and column count array. So you have the coordinates I and j, and you can access the corresponding value, ith row and jth column. Ith row and jth column. You can already see how many number of painted cell in the ith row and how many number of painted cell in the jth column using these two arrays. So if at any moment their value is becoming equal to the desired one, or let's say for every row, if the number of painted cell is becoming equal to the number of column, then we will just get our answer, and we can just return ith iteration, because we are doing this iteration ultimately. Now this is our approach. So what is going to be the time and space complexity? What is the time complexity? First of all, we are getting the coordinates. Coordinates is taking order of m cross n. Okay. Order of m cross n, and we are iterating over this array again, and we are filling the cell. That is also going to take in order of m cross n, So ultimately, the worst case, the order will go till the number of items, and number of items is m cross n. And what is the extra space? Extra space, for the extra space, what I'm taking is, we are taking two array. One array is of size m, one array is of size m plus n. But along with that, we are also taking a hash map where the keys will go from 1 to m cross n. So the space will also be m cross n. So this is our time and space complexity. We are visiting every item only once. Now let's code this approach. First of all, I'm going to take a map. Map will be mapping integer with coordinates. For the coordinates, I'm taking integer array. Let's call it map, new hash map. Okay, I will also be requiring number of rows and number of column. Int m equal to mat dot length. Int n is equal to matrix of 0th row dot length. 0th row will definitely exist because the size is going from 1 onwards. Okay, so first of all, I need to track every single value with the corresponding coordinates in the matrix. So I will iterate over the matrix I equal to 0, I less than m, I plus plus, nested loop for the column, j equal to 0, j less than n, j plus plus. This is my loop to iterate over the matrix, and now I need to store the entry. Store the entry in my map. The key, what is the key? Key is going to be the value. So key is my value, matrix of I and j. This is the key. And now what is the value? Value is equal to new integer array, and this integer array is going to store my coordinates I comma j. Map dot put key and value. Every time we are going to get unique key, because every key is present from 1 to m cross n, and that is present only once, so we can directly add in the map. Okay, now map is completely filled. I require two arrays. Now first one, let's say first array is row count is equal to new. Row count is number of painted cell in the corresponding row. New int of size m. Column count is equal to new int of size n. Number of painted cell in the corresponding row, painted cell in the corresponding column. Okay, this is the column count, and now I need to start painting every single cell using this array. Just iterate over this array, iterating using for loop because I require the index in the end. I less than a dot length I plus plus, and now I have to paint this I value. Let's form the key again, dot I. This is the key. Let's call it location. Location is equal to map dot get key. Now this location is the coordinates of that cell. Okay, if I have got the coordinates, I am going to mark this cell a painted cell. So I'm going to increase the corresponding column and corresponding row and corresponding column. So what is the row? Row is location of 0, and what is column? Location of 1 is the column. One more painted cell in that row, so row count of this row is getting incremented, and the column count of this particular column is getting incremented. Now I am doing this operation, and after performing this operation I can check if any one of this value is becoming equal to the desired one. Row count, painted row in the corresponding row is becoming equal to the number of column, then return, then we have our answer. If this value is becoming equal to n, or this value is becoming equal to m, it means we have the answer. And what is the answer? Answer is I. Return I. I is my index. I is my index at which any one of the row and column is getting completely painted. Let's say in this case the second column, it is the smallest index I at which either a row and a column will be completely painted. So this is my index. In the end I must have to return something for integer. Let me write -1. We have processed the matrix and counted the painted cell in the corresponding row and column. This value should be an array, and same for the location. This location is an array containing I and j. Okay, let's run over sample test cases. Sample test cases are passed. I try to submit the problem. It's submitted successfully. I hope you have understood the approach. Thank you guys. If you have any doubt, you can comment down below.